the graph to write an equation of the line, interpret the slope and y-intercept in words. For writing an equation of a line, we want to do it in y equals mx plus b. And in the case of this graph here for child's weight, the thing that I notice is that they actually give us what I need to get the b value, or I'm sorry, the slope. What I see down here for slope is they're showing us there's a rise of 10 and a run of 2. And so that tells me the slope of this is going to be 5. Now, so when I go in to write my equation, y equals 5x plus, the next piece I need is my y-intercept. It seems like it's at about 20, or I'm sorry, it's about 15, but just because it seems that way, I don't have it marked off exactly. So I'm gonna use this XY point on here, 5, and I'm not gonna do this, go do it yourself. I'm not gonna have time. So I'm gonna use my XY, y equals 40 equals 5 times 5 plus the missing b value. 40 equals 25 plus b. When I take, it was 15. When I take 25 away from both sides, I do find out that that is 15 the way it looked. Now, the equation is 5x plus 15, but part B, and a lot of people miss this, and I don't know what went on when we took this test, but this will help you with your test corrections too. You go and you say the slope is 5. This means that, and then you have to interpret it in context. This means that as a child ages 1 year, and how am I getting this? Well, I'm looking at the labels on the graph. As the child's age goes up 1 year, it's assumed that their weight increases 5 pounds. For each year, their weight increases 5 pounds. Now, for y-intercept, the y-intercept here is 15. Y-slope always will make sense in the context of the problem, always. Y-intercept, not so much. Y-intercept doesn't always make sense. The y-intercept is 15. This would imply that a child's birth weight at age 0 is 15 pounds, and that's a little extreme. This implies that a child's weight at birth, age 0, is 15 pounds, and that does not seem very realistic. Yeah, I don't think, doesn't seem real. Slopes always make sense, y-intercepts not necessarily. Now this video is going to get posted up and you can come back to it. I apologize, but again, we got our exam tomorrow for 7th hour, so we got to get through everything. In problem number 2, actually 2 is a little bit easier because when I look at this, I see in problem 2 to go for my y equals mx plus b, not only do I have the stuff I need to get the slope, slope is rise over run, 11 over 4. When I look at this, you guys, the y-intercept is always the y value when x is 0. That is 20. B is 20. So for this one, it's just saying, now this is about making loaves of bread. And so this 11/4, I'm going to turn that into a mixed number because it's all about cups of flour. 4 goes into 11 twice with 3 left over. 2 3/4 x plus, oh man, I messed this one right up. Down. So, negative 2 3/4 x plus 20. Now, what is the slope? The slope is negative 2 3/4. That means that I'm using negative 2 3/4 cups. I'm using 2 3/4 cups of flour for every loaf of bread. We use 2 3 cups of flour for every loaf. And actually, in this case, the y-intercept does make sense. The y-intercept is 20. That means that we start out with 20 cups of flour. Y-intercept is 20. We start with 20 cups of flour. All right, so writing your y equals mx plus b and then interpreting your slope and y-intercept. I'm going to move to the next page. When we get to the next page, there's some specific directions. I'm going to actually show you guys some finished products for the next page after I talk about a couple things here. In each of these, there's two things to do. We have to make a graph of the function, and we also have to graph its parent function. In each of these, there's two things to do. I'm going to give you guys the table of values for every single parent function. The parent function is f of x equals x squared. This is our parent quadratic. And the parent quadratic function has a table of values, x and y. The vertex sits at 0, 0. If x is -2, y is 4. If x is -1, y is 2. If x is +1, y is 2. If x is +2, y is 4. This parent function needs to be graphed on every single one of these graphs. And then you have to graph the actual function with them. So I'm going to give you the tables of values. We're going to take a moment to stop off, and I'm going to show you some finished product. So in number 1, first of all, this is a linear. One of the things that you guys want to do is make sure that on your cheat sheet you have all the parent functions that come up in this chapter. You have a table of values for every parent function. The linear parent is actually the line the linear parent is y equals x. I'm not even going to draw it. I don't know why I did that. That's our parent. Now, the function h of x equals x plus 2, let me give you a table of values so when you go home you can at least graph this. -4 and -2, -2 and 0, 2 and 4, and 4 and 6. So you'll have two lines on this once you graph that. Let me go over here. This is a quadratic. Your quadratic parent is y equals x squared. You actually have that up here. Oh, I shouldn't have put parent function. This isn't it for all of it. This is just quadratics, my bad. And then the g of x equals -3x squared. I'll give you the table of values to put on that one. -1 goes with -3. Its vertex is at 0, 0. +1 also goes with -3. You have the tables of values for each of these. I'm going to go below to this is an absolute value. The absolute value parent, and again, these are things you want to get out of your absolute value of x. You want to make sure you go get these out of your notes packets and put the tables of all the parents on your cheat sheet. And then the table of values for this one, so you can go graph both. X and y, -6, 1, -5, 0. -4, -1. I think I got a little crazy here. There's the vertex. Remember, absolute value guys are like V's. Our parabolas are like U's, but absolute value looks like V's. So there's the table of values you could use for those. And then just kind of moving back over to my number 5 here. This guy's a quadratic as well. Quadratic. Y equals x squared. That parent needs to be on there. And a table of values for this x squared plus 2 is going to be -2 goes with 6, -1 and 3. Vertex is at 0, 2, +1, 3, +2, +6. Now those are all the tables of values for you. So what I'm going to suggest that you do is you go back and you get all those graphed with their parents. So every one of them is going to have two things on it. And then you have to describe the transformation. So go in and do the work for that. And then I'm going to show you guys the finished product here. So you can do, take the time to graph it yourself, because if you just sit here and try to stare at this screen, it's going to take you 10 minutes of zooming in and whatnot. But once these are all graphed, you guys, the big thing is that you finish them up and you talk about the transformation. Like in problem number 3 here, it's the parent that I have highlighted. I'd be watching, if anything else, because these tables and everything are the same. I have the parent highlighted. My x plus 2. H of x is the parent translated up 2. The parent function just got moved up 2, and that's from the plus 2. In problem number 4, when you look at the quadratic parent compared to -3x squared, when you get that on the graph, g of x is the parent reflected over the x-axis, and it's narrower. The negative sign makes it reflect. The 3 makes it narrower. Down here, the parents, in yellow, h of x, it moved over this way, you guys. H of x is the parent translated. This plus 3 in here made it move left 3. This minus 2 out here made it go down 2. And then last but not least in this crowd, here's another quadratic with its parent. This is just the parent moved up 2 units. All it was that parent x squared plus 2, g of x is the parent translated up 2. So again, pause off, make sure your graphs get all done, and don't just be copying this, just sort of work through it. These aren't that tricky once you got every single table that you guys need for this. I'm going to go on. I had looked up the rules. This was all from Chapter 1 notes. And in your Chapter 1 notes, you guys had a couple pages in there. I couldn't find any of my notes. I had to go into my book. It was pretty easy for me to go into my book and start looking at, and it's in our notes too. A reflection in the x-axis means that we have to multiply the inputs by -1. Now, when I say multiply the inputs by -1, what I mean by that is the x values. If I say multiply input, that's just x values. So they want us to call this g of x when we transform it. To do this reflection then, I have to go and say, all right, right now, I have to take my x is opposite of x, but I got to go opposite of -1 times x plus 3. Multiply your input by -1. Now, what is the opposite of -1 times x? Well, that's going to be just positive x plus 3. So my new g of x function is x plus 3. That will reflect it in the y-axis. Now, when we have a reflection in the x-axis, that is outputs times outputs by -1. That means your entire function. The entire function is what produces our outputs. So then for this one, g of x is going to be, I'm going to use the idea of distributive, -1 times this whole entire equation. I'm going to distribute it. So then g of x winds up being -2/3 x plus 4 for that one. Having the rules about what to do for each of them is super important for you guys. Having the rules. Harry, your bus was...
I drove, but...
Jules was late too. Just you guys got out late?
Oh, yeah, I had an accident over so I had to...
That's in my video now too. Put you guys as a documented tardy excuse. Okay. Now, number 9. Number 9 is a vertical stretch. Vertical stretches, we multiply outputs. Multiply outputs by 2. That means the whole function needs to get doubled. And this one's got a little bit of a funky thing that winds up happening. G of x is going to be then, so I've got to double my entire function. So I'm going to put a 2 out here, and then inside I still got this 2 times the absolute value of x minus 2, close that up, plus 4. Now, I'm going to grab a red marker here to make this seem a little more clear for you. I'm actually going to only distribute to these values. I want you guys to think about something. Walk up here if you have a question. I want you guys to think about something. If I multiply 2 times -2 here, I'm going to wind up with -4 outside, and that is already going to double what was there. It is. And then I've got to multiply my 2 by my 4. So right now, to change this function, I just doubled these two values because doubling this -2 to -4 will go and affect everything inside. So I didn't distribute that 2 through twice because the 2 got multiplied by the -2. This 4 would go into what was there. Translations up, I'm going to add. Translations up, I'm going to add 5 to the outputs. And then the rule for a vertical shrink, which is the same as a horizontal stretch, I'm going to multiply outputs by that quarter. Oops. Times outputs by a quarter. And so there's 2 things I have to do in this one in order to create this translation 5 up and vertical shrink factor of 4. My function is just f of x equals x. That's just the linear parent. So g of x is going to be, let's see. I have x. I have to add 5 to the outputs. There we have it. That's going to move it up 5. That's going to move it up 5. Yep, translation 5 units up. After I do that, though, I have to also vertical shrink it So that means that I have to multiply the entire equation by a fourth. So now my function is going to be a fourth of that. And this time I do want to show